This PowerPoint presentation is going to be another quick math quiz, multiple choice questions, where I do the formulas and work through and get the answers. Preface, as always, I claim no ownership to any of the questions or materials presented in this video, as everything is sourced off the open internet. In the following slides, I will, to the best of my ability, answer the questions correctly and use the proper formulas. So doing this as a study for myself. If it can help you, that's great. A water plant uses 25% caustic soda to raise the pH of the water. The target dose is 20 milligrams per liter. They treat 600 gallons per minute. Specific gravity of 25% caustic soda is 1.28. How many gallons of caustic soda will need to be fed? 10.67 gallons, 29.3 gallons, or 54.1 gallons? First, pull out your known and your unknown. What we know is the dose, 20 milligrams per liter, the flow of 600 gallons per minute, purity of 25%, and a specific gravity of 1.28. What we're looking for is how many gallons will need to be fed. So feed rate is pounds per day is equal dosage milligrams per liter times flow million gallons a day times 8.34 pounds per gallon. Go ahead and convert your 600 gallons per minute to million gallons a day. So we're going to multiply by 1,440 minutes in a day divided by a million. Gives you 8.864 mgd. Plug that into your formula. 20 milligrams a liter times 0.864 mgd times 8.34 pounds per gallon. That gives you a feed rate of 144.12 pounds per day. Alright, to convert this into gallons, we're going to use this formula off the formula sheet that I have. Sodium hypochlorite is pure chlorine required pounds per day divided by the purity times 8.34 pounds per gallon. But this is not sodium hypochlorite, it is caustic soda. So we're going to multiply the 8.34 pounds per gallon, which is water, by the specific gravity of the caustic soda, which is 1.28. So 144.12 pounds per day divided by 0.25 times 8.34 pounds per gallon times 1.28, and that gives us an answer of 54. So the answer is C, 54.1 gallons. If a 24 gallon per day pump is set at 80% stroke length and 100% speed, the theoretical pump output would be how many gallons per day or milliliters per minute? 19.2 gallons a day or 50.5 milliliters per minute, 19.2 gallons per day or 25.5 milliliters per minute, or 17.1 gallons per day or 50.5 milliliters per minute. So what we know is the pump is 24 gallons per day, it's 80% stroke and 100% speed. We're looking for the output. So 24 gallons per day times 0.8, because you're only getting 80% stroke, gives you 19.2 gallons per day. So now we need to find milliliters per minute. So we're going to do the 19.2 gallons per day divided by 1,440 minutes in a day. It gives you 0.01333 gallons per minute. There are 3,785 milliliters in a gallon. So you multiply that by 0.01333 gallons per minute. And that gives you 50.45. So the answer is 19.2 gallons per day or 50.5 milliliters a minute. A chlorinator in a water treatment plant that produces 600,000 gallons per day is set to feed 30 pounds a day. If this feed rate is decreased by 10 pounds per day, the dosage will be reduced by how many milligrams per liter? So find your known and your unknowns. 600,000 gallons per day, pumping 30 pounds a day. We're going to decrease it by 10 pounds. What is the reduction of the dosage? So your feed rate pounds per day is equal dosage milligrams per liter times flow mgd times 8.34 pounds per gallon. So we're going to rearrange that. Find the dosage is equal to the feed rate pounds per day divided by the flow million gallons a day times 8.34 pounds per gallon. Convert your 600,000 gallons per day to MGD. Divide that by 1 million. So 0.6. So 30 pounds a day divided by 0.6 MGD times 8.34 pounds per gallon. And we're going to do it for 20 pounds a day if you reduced it by 10. So 20 pounds a day divided by 0.6 MGD times 8.34 pounds per gallon. So you had a dosage of 5.995, and the reduced dosage is 3.996. So you subtract the 3.996 from the 5.995, and you get a reduction of 2 milligrams per liter. A filter 35 feet wide by 20 feet long needs a backwash rate of 20 gallons per minute per square foot to determine the required backwash pumping rate in gallons per minute. So we find our known and our unknowns. So 35 foot wide, 20 foot long, and 20 gallons per minute. What we need to know is the pumping rate in gallons per minute. So the backwashing pumping rate gallons per minute is equal to the backwash rate gallons per minute per square foot times the filter surface area square foot. Square foot of a rectangle, length times width. So 35 times 20 gives you 700 square feet. Plug all your information into your formula. 20 gallons per minute per square foot times 700 square feet. That's going to give you an answer of 14,000 gallons per minute. What is the filter capacity in gallons per minute of a system with a sand bed 40 feet in diameter when the filters are rated to have a capacity of 2.5 gallons per minute per square foot? 78.5 gallons per minute, 250 gallons per minute, 1,500 gallons per minute, or 3,140 gallons per minute. So pull out your known and your unknowns. So we have a 40-foot diameter with a capacity of 2.5 gallons per minute per square foot. We're looking for the filter capacity. So first we need to find the area. So 0.785 times the diameter squared, because it gave us the diameter. So 0.785 times 40 squared gives you an area of 1,256 square feet. Filter capacity is equal to the 1,256 square feet times 2.5 gallons per minute per square foot. That's going to give you a filter capacity of 3,140 gallons per minute. A filter 25 feet long and 35 feet wide treats a total of 1,400 gallons per minute. What is the filter loading rate? 1.6 gallons per minute per square foot, 3.2 gallons per minute per square foot, 5.2 gallons per minute per square foot, or 81 gallons per minute per square foot. Pull out your known and your unknown. You have 25 foot long by 35 foot wide with a total of 1,400 gallons per minute. What we don't know is the loading rate. Surface loading rate, gallons per day per square foot, is equal to the flow rate, gallons per day, divided by the surface area. So the area of a rectangle, length times width, 25 feet times 35 feet, 875 square feet. Plug in your numbers. You have a flow of 1,400 gallons per minute divided by 875 square feet. That's going to give you an answer of 1.6 gallons per minute per square foot. If a water treatment plant that produces 990,000 gallons per day decreases its flow to 850,000 gallons per day, the amount of chlorine fed will change from 20 pounds a day to how many pounds per day? So we're going to pull out our known and our unknowns. 990,000 gallons per day or 850,000 gallons per day, and we have 20 pounds per day of a current feed, what will be the reduction in pounds per day? So first feed rate pounds per day is dosage milligrams per liter times flow million gallons a day times 8.34 pounds per gallon. We're going to rearrange that formula to find dosage. Dosage is equal to the feed rate pounds per day divided by flow mgd times 8.34 pounds per gallon. First, we're going to find our current dosage at the 990,000 gallons per day. We're going to convert that 990,000 to mgd, so divide it by 1 million. Gives you 0.99 mgd. 20 pounds per day divided by 0.99 mgd times 8.34 pounds per gallon. That's giving you a dose of 2.42 milligrams per liter. So now we can find the feed rate pounds per day. We're going to do the 850,000 gallons per day, convert it to million gallons a day, so divide it by a million. And now we have the feed rate pounds per day is the dosage milligrams per liter times flow million gallons a day times 8.34. Plug in your 2.42 milligrams per liter times 0.85 million gallons a day times 8.34 pounds per gallon. That's going to change your feed rate to 17.15 pounds per day. All right, so just another short little quiz. Like I always say, this is helping me study. Putting these PowerPoints is good for me to learn. If it helps you learn too, that's great. Thanks.